In case you're still struggling with some of the linear programming problems, especially how to write a system of inequalities, I thought I'd go through 2 examples in detail, step by step. Hopefully that will help you. This would be a good video to pause and try to do it yourself, various points, and then see if it matches what I've done. I'm using 2 problems from the LP More Practice worksheet that I put into your class worksheet folder. And I wanted to scroll down to number 3 to start with. All right, here we have this problem. If you need, you can pause the video to read it for a moment. We need to first think about what 2 things are we talking about in this problem. They are talking about hamburgers and hot dogs. Hamburgers and hot dogs. So those are the 2 things we're talking about. Hamburgers and hot dogs. More specifically, if we look towards the end of the problem, how many, well, that should say how actually, how many of each item. So we are talking about the number of hamburgers and the number of hot dogs. We're not talking about the price of a hamburger or the price of a hot dog. How many? That means number of. So now we're going to define our variables. I'm going to let x equal hamburgers and y equal hot dogs. And on my graph right now, I'm going to go ahead and put that. Number of hamburgers. And on my y-axis, I'm going to put number of hot dogs. All right. Now, the next thing I want to do, moving down my worksheet here. Now, I know these little words aren't on your worksheet. I added them to mine to help guide you through this problem. But you could have these words on every single problem. Always start off by defining your variables. And even though this isn't the same order of the steps in your book, I think it's helpful to define your profit function next. And it says it usually deals with money, but not always. I know that this one is going to deal with money because I see the word maximum profit. Profit is how much money you make. I also look back to the previous sentence and I see the profit word again. So the profit on a hamburger is 33 cents and the profit on a hot dog is 21 cents. How many of each item should it sell to maximize my profit? So now I can write a profit function. Remember, function notation, f of xy equals 33 cents per hamburger and 21 cents per hot dog. That's how we figure out how much money we made. We say, well, I sold 10 hamburgers and I sold 20 hot dogs, and you multiply this one by 33 and this one by 21 cents, add it together, that's your profit. All right, so we have our profit, we have our variables. Now we have some words left. You'll notice that the first sentence here, a snack bar cooks and sells hamburgers and hot dogs during a football game. That's just kind of setting the scene. Typically, our first sentence is just going to set the scene. I know I can't use those words to make an inequality because it doesn't have any numbers, and it's really just giving me some background on the story. Next, though, I do start to see some words come into play. To stay in business, it must sell, the snack bar must sell at least 10 hamburgers, but cannot cook more than 40. So we're dealing with our x variable here. Hamburgers means x. At least 10. X is at least 10, but not more than 40. That's what that says. So to write that, I would say 10 is less than or equal to x is less than or equal to 40. Now, you also have the option of saying x is greater than or equal to 10, x is less than or equal to 40. I like taking these two and putting them into one inequality. I think it's just a a little more streamlined, if you will. So I'm going to keep it this way. All right, that's what I got from the yellow words. Then it goes on to talk about hot dogs. So I'm going to change my color of highlighter here. It must also sell at least 30 hot dogs, but cannot cook more than 70. Well, that's just like the yellow sentence we just had, except now we're talking about hot dogs. At least 30. Why is at least 30, but no more than 70? Why is more? Why is at least 30, but it's not bigger than 70? No more than 70. It can equal 70, but it can't be more than 70. All right, now I have another sentence. So I can't do anything more with my green inequality here. That's enough on that. So I'm going to change colors again and look back to my words. The snack bar cannot cook more than 90 items total. This is where you have to think about that. What does that mean? Well, if you add up the hot dogs and you add up the hamburgers, you can't make more than 90 items, okay? So we're literally saying if I take the number of hamburgers and the number of hot dogs, that can't be more than 90. So now I've used up all the words. I underlined in gold my backstory. I underlined in green stuff that made my profit function. And then I had 1, 2, 3 other highlighted pieces that made up my 1, 2, 3 system of inequalities. All right, now we have to graph this. One option is to take this and dump it straight into Desmos. That's fine. However, this one really isn't too bad to graph as long as we count by tens. And same on the y-axis, 10, 20, 30, etc. All right, so my first inequality is going to be the yellow line, and it's bigger than 10. So here's 10, and less than 40. Here's 40. All right, I have my 2 lines on there. I'm not going to shade, but I am going to draw my arrows to show that the shaded region is now just in between these 2 lines. Now I'm going to graph my green equation here. Y is greater than 30, but less than 70. So 40, 50, 60, 70 would be right here. So it's not too hard to scale this graph to make it work for us. And again, I know it's in between, so it's in this region. Right now, if I were to shade, it would be this box right here. And finally, I have my last line, this blue equation. X plus y is less than or equal to 90. Now, I could solve for y and graph with slope-intercept, but instead I'm going to say if x is 0, y is 90. If I don't sell any hamburgers, I can sell 90 hot dogs, which will be right here. And same thing holds if we do it the other way. If I don't sell any hot dogs, how many hamburgers? 90. So this is 40, 80, 90 would be right here. And then I'm just going to connect them with a line. It is less than 90, so I know that I would be shading under the line. My shading is this area right here. This is my feasible region, just this part. All right. Once I have my feasible region, now I can look at each vertex of the region, each corner. And on my graph, it's going to be very easy to identify these. This is the point 1030. This is the point 4030. 4050. This is the point 2070. And over here we have the point 1070. So I want to take those 5 vertices and run them through my profit function here. So I'm going to write them out in a list. 1030, 4030, 4050, 2070, and 1070. And remember, there's a lot of other combinations of hamburgers and hot dogs in this gray region, but we're only taking the extreme ones and running them through the profit function. So we're literally taking 33 cents times 10 plus 21 cents times 30 and 33 cents times 40 and 21 cents times 30 and so on. Hopefully you've been taking a moment throughout this video to pause and try to do this problem on your own, but if you haven't yet, go ahead and figure out the profits for these different combinations. Go ahead and pause the video and see what you get for your profits and see if you get the same thing that I get. All right, hopefully you got these same numbers. You'll notice that the highest number is right here, $23.70, and that happened when we sold 40 hamburgers and 50 hot dogs. So we would say type it right here. Our maximum profit is $23.70, which we can earn if we sell 40 hamburgers and 50 hot dogs. All right, let's go ahead and try number 4. I specifically chose this one because here we're not going to have money in our profit. It's actually not really a profit function, actually. It's going to really be more of a optimization or a maximize situation. So again, pause the video if you need to read through the scenario. I'm going to assume that you've read it though. And let's start looking for our optimization information. Oh, by the way, what 2 things are we talking about in this problem? We are talking about 2 types of questions. We have type A questions and we have type B questions. And how many of each type? So we're talking about number of type A questions, number of type B questions. I'm going to let X stand for A and Y stand for B. That kind of came from my backstory here. You are about to take a test that contains questions of type A and type B. Now, I stopped underlining there for a very good reason, because I know that how many of each type of question must you answer correctly to maximize your score? Think about how you compute your score. Think about every test or quiz you've taken. You take the number of points that you get for each problem and add them up. So type A gives me 4 points per question, and type B gives me 7 points per question. So I know that my optimization function is going to be 4 points for every type A question and 7 points for every type B question. And that's going to tell me my maximum score if I compute that. Okay, so let's look at the other details that we have here. We have you must answer at least 4 of type A. The number of type A questions is at least 4. The number of type A questions, that's X, is at least, meaning greater than or equal to, 4. The number of type B questions is right here. The number of type B questions must be at least 3 of type B. So how do we write that? Well, we say type B questions must be greater than or equal to 3. Now remember, we always have some implied constraints. We did on the hamburger and hot dog problem and on this one as well, meaning we can't sell negative hamburgers and hot dogs. We can't get negative type A questions right. We could get 0 of them right, but we can't get -1 of them right. So we know that they must be greater than or equal to 0, but these take care of that. And let me explain why we don't need to write the implied constraints for this scenario. Think about if I tell you, okay, I've got some money in my pocket. I'm not going to tell you how much, but you have to guess. If I tell you that the money in my pocket is more than $4, are you starting to think of some amounts that might be more than $4? Maybe I've got $5, maybe I've got $20, but it's more than 4. And you say, okay, give me another clue. Give me another clue. And I'd say, the amount of money is more than 0. Would that help you figure it out? No, because you already knew that. You knew it was more than 4. So saying that it's more than 0 is unnecessary. If I did not have these constraints, I would want to include that x is positive. X is greater than or equal to 0. So that's a little side note of why we don't have to include them here. Okay, going back to the problem, time restricts answering more than 10 of either type. So you have to be less than 10 for both types. Now, we don't usually write them this way. So I'm going to flip it. 4 is less than or equal to x is less than or equal to 10. That's a nicer way of writing it. It's not wrong the other way. This is just the better way to write it. Okay. Next, we have a little bit more information coming. In total, that means A and B type questions. Add them together. You can answer no more than 18. So if I take the number of type A and the number of type B, it must be less than or equal to 18, the number of. So now I've used up all the words in my word problem. That's our goal, is to use up every word and either turn it into part of the profit function, make it part of the backstory so we know what we're talking about, or write constraints with it. Again, at this point, you can throw this right into Desmos, but this is not hard to graph. X is number of type A, and Y is number of type B. And the numbers that I'm graphing, 4, 3, 10, 18, they're really not that big. However, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I can't get to 18. So I know I need to scale this down, but not by much. So I'm just going to count by 2s. 2, 4, 6, 8, and so on. So for my first inequality, and again, I'm going to mark it so I know where this came from. X is greater than 4 and less than 10. And that's shaded in between. And then the next one I'm going to graph is my y function. I'll make that orange. Greater than 3, which is right in between 2 and 4. And less than 10, which is right here. And again, it's shaded in between. So much like the last problem, I now have this box, but I still have one more function. x plus y must be less than or equal to 18. Well, if I don't get any type A correct, I would have 18 type y. So that's 10, 12, 14, 16, 18 right here. And same thing in reverse. If I don't get any type B questions right, I would have 18. So this is 10, 12, 14, 16, 18 type A questions. Connect those with a line as neatly as possible. Sometimes you have to adjust it using your mouse if it doesn't go on the first try, because you want your vertices to be clear. Okay, this is less than, oopsies, turn my purple line gray. 1 second, turn it back to purple. There we go. Now I'll gray my pencil, and I want it less than the line. So this is my shaded region right in here. Okay, the vertices are very easy to read off the graph. 1, 2, 3, 4, 5. So I have the vertex 4, 3. This one is 10, 3. The one above it is 10, 8. This one would be 8, 10. And finally, this one is 4, 10. Pause the video and run them through your profit function to see, even though it's not really a profit in this case, run them through your optimization function to see which one gives you the highest total overall score. Again, this is my score right in this column. So you can see that the best score that I could achieve would be right here, 102. If I get 8 type A questions right and 10 type B questions correct. So that's what we will write for our answer. If we answer 8 type A questions and 10 type B questions correctly, we will attain a score of 102%. So I hope that this helps you to write out your inequalities. If you're still struggling, just send me an email and I can help you figure out how you might be struggling. I intentionally skipped question 1 and 2 because I like how it kind of leads you through step by step. Compared to 3 and 4, they just kind of tell you the problem and leave you to figure it out.